If it doesn't, I see you pulled up the iPad. All right, so it works. And we'll show it again too if you didn't get a chance to do it this time. So here's some of the things that we're going to talk about today. First, we'll go into a bio and we're going to give you a background of motivation. We're all here for the background of motivation, so we'll probably kind of zoom through that a little bit. And then we'll talk about Ali Social itself, basically what powers Ali Social kind of enable these things. And then we'll talk about some future things, and then also get some insight from you all on how this can be used or what needs to be done to create social networks and contribute that.
Okay, so it's just a little bit about myself. So my name is Zachary. As Dr. Baker mentioned, I'm one of the PhD students at the University of Kentucky. I actually just started this previous spring. That just finished. This is my first semester in the graduate program. Before that, I've done some industry positions. Most recently, I was at Google as a software engineer doing iOS development. Things like Google Play, books, Google Search for iOS, those kinds of things. I worked extensively on those at Google. Before that, I was at Western Digital, also doing iOS development on some cloud-connected hard drives at Western Digital. Before that, I've done some internships at Lockheed Martin in Northrop Grumman and graduated at the University of Buffalo in upstate New York.
And some of the things you're interested in research ones?
My research is going to be around IoT and networking for constrained devices. Particularly, I like to look into security issues and looking into how to do secure communication when you don't have the typical backend that you see for like public key infrastructure and those types of things. So that's what my research interests are. As I mentioned, I just started, so I'm still figuring out exactly what I'm going to do, but that's kind of the general field that I'm looking into.
So a little bit about me. So my research area is in opportunistic communication, very similar to what Agnes was talking about when it comes to building secure smart cities and really low cost smart cities. So when we have limited communication, you can't use, you can't depend on the internet. How can you build things like social networks, smart cities out of this? And so I'm currently an assistant professor at University of Kentucky. And then I postdoc at UC San Diego and at USC. I did some graduate school at University of Florida. And I'm actually from California originally, so I did my undergrad and master's out there. And so some things that I've done in industry, going alongside with school is from some of the technology out here I have in the startup, which is 1 degree technology. But then I've also been an RF engineer. And then I did some things at Hewlett Packard and NASA. So background. So many of you already know why we're all here today for this hackathon. But with Hurricane Maria and Hurricane Matthew, or previously before that Hurricane Matthew, there's been, when areas of Hurricane Matthew disasters, there's people that sadly end up dying, or they, when people are alive, they basically are constrained resource-wise when it comes to finding food, water, even coming in contact with, say, family members, right? There's certain things, basically, your traditional means are basically interrupted to prohibit communication in this, and really, trying to deploy relief workers, but then sometimes people, if they just had simple communication, they weren't able to do a lot more than what they were doing. And so, of course, when this disaster hits, communication needs to be more increased in these scenarios. And so, many of you were here during, say, Hurricane Maria. If you think back about that scenario, you think of these dots here as you all, people that's here when the disaster hits. And if you pick out a few people in this scenario, right? So say they're scattered, and this is not necessarily in this room, but say they're kind of scattered around the area or around the city. So let's look at a few particular people here. Disaster hits, network infrastructure goes down. what is one of the first things people typically do when it comes to social networking when a disaster happens?
I'm safe.
I'm safe. How do you do so?
Usually people go on Facebook or something.
So they go on Facebook, Margaret said anything else?
Yes.
I'm sorry, you said what?
Like right after this one?
Yeah, so when it comes to social media, like when
No, we use
Yes.
WhatsApp.
what's that?
Yeah.
You try to serve the family members, right? And or using WhatsApp. So all these are very similar.
Call your family.
Or you call, all right? You call people. So very simple. Basically, you all say the first thing that people typically do is they go on Facebook or they try to communicate using this centralized infrastructure, right? But what happens in this scenario is that when infrastructure is damaged, it's slow, so you either can't get through, or you have trouble getting through, or even worse, you can't get through at all, right? And so even though there's things in place like safety check, WhatsApp, all these types of things, really, you can't mark yourself safe if you can't communicate. So what if you can leverage the people around you to basically disseminate information with some delay, of course, to kind of get the information you need. And then if you need to, depending on what the information is, maybe that information can be secured as well, right? And so that's the premise kind of for what the hackathon is today and really the motivation for this talk. And so really, you might remember this Verizon commercial. You might think this guy with Verizon, but more recently he was with Sprint, so I guess he just upgraded his network. But if you remember this commercial from some years ago, Verizon said that their network is so good that you can basically, it's like taking your network with you anywhere, right? And really this concept is trying to bring this back. If you, in these places, people are still coming in contact with you, you can leverage the concept of your people moving with you, then you can create social networks on the fly. So what are some of the limitations when it comes to decentralized communication, depending on internet or cellular connectivity? Well, the problem is that if two devices want to talk, just like the example we just showed, Alice and Carol, they basically have to use some type of cloud infrastructure to talk first. And a lot of times if the infrastructure is limited with the natural disasters, so there's central point of failure, congestion, of course. If there are some spots that's up, everybody's trying to use those limited resources at the same time so they can communicate. And then there's also IP blacklisting, which we'll talk about some of those things on the next slide, and then more in the kill switch. So what's interesting is that 60% of the world has mobile devices, right? But only 50% have internet access, right? And then of course it gets a lot worse when they have to disaster. And so some of you might have heard it. This is talking about the kill switch here. In Arab Spring some years ago, 2014, I believe, people were trying to protest the government there. And what they did was, the government didn't like this. What they did is they went to the ISP, internet service providers, and they basically disconnected them and said no communication over Twitter, right? Which is what's called the kill switch. At any point in time, this cloud infrastructure was regulated. They cut off communication, and people were saying, go to this area so we can meet here and protest, and basically stop that on social media, or stop it in terms of social media, right? So limitations like this, when you got centralized communication, all you have to do is cut the cord to that connection. Another one, which I heard some of you all kind of talk about FireChat, is the FireChat application. So the FireChat application was used in Hong Kong, this is during Burning Man a few years ago. And what happened was thousands of people, I believe over 100,000 people downloaded FireChat. And it was said that the government was limiting internet communication in this area. And so people would use FireChat to still communicate with each other. And FireChat kind of works like, it's kind of like a chat room style application. And people were able to talk as they please, even if you're limited in there by using mesh networks or device-to-device communication. So, kind of to give you some information about what we're going to demonstrate to you all, or talk about with you all, is how to use social. So if you all went to that link and you put in your information, you put in your name and your email, you should have got a link to download TestFlight, which is Apple's beta testing application. And then you also would have received, so you download test flight basically allowed you to beta test Ali Social, right? And so Ali Social, Ali comes from the concept of basketball, and so like the basketball concept, we added this other stuff to it afterwards, right? So Ali stands for a low latency evaluation system for ad hoc opportunistic passing. And then, so with this, of course, when you're downloading this on your device now, test flight is officially through Apple, so this is not jailbreaking or anything through your app, right? And so you don't need any jailbreaks needed to use this device-to-device communication. It's an online, offline social network, meaning that, well, first we say it works very similar to Twitter. It's a very low-scale version of Twitter. Twitter looks simple. Twitter is actually very complicated and are made by some very talented engineers. So you'll see the differences between when you look at Ali Social and UI is what Twitter looks like. But online, there's internet availability. You receive information basically just like you normally would on Twitter. So push notifications. When your friend or somebody you follow posts a message, you'll see that on that screen. Offline is that whenever you don't have internet communication, or say it's completely removed, you're still able to come in contact with people and disseminate information. So you'll still receive information from your followers, or from people you follow, and you'll still get help propagate information as well. So the way that it does that is through device-to-device communication, primarily Bluetooth, peer-to-peer Wi-Fi, and infrastructure Wi-Fi. And so there's a middleware, which we'll talk about in a second, that basically enables all that, and Ali Social runs on top of that application. So seamlessly, when you're walking around and you're coming, assuming that you have Bluetooth enabled and your Wi-Fi enabled on your device, use Bluetooth communication to propagate information to other Ali Social users, and then also switch off for using peer-to-peer Wi-Fi and infrastructure Wi-Fi. So infrastructure Wi-Fi is kind of like how we're all connected here. We're connected to an access point, but then that access point is disconnected to the internet. We're all still connected to that router. So of course, many people can be connected to a router at a further range than Bluetooth. You can still talk to people on the other side of that router automatically. And so this does secure message delivery. We'll talk about kind of how some of the means can be used to secure communication in Ali Social. And then it could run multiple DTN routing protocols. So how many of you are familiar or heard about FireCheck? So many of you know about FireCheck. So with this, one thing that's particularly different from here, and this is not actually meant to compete with FireCheck. This is all a research project, right? But this has many different routing protocols. So there's two areas of networking. There's Manage, which is mobile ad hoc networks, which is kind of what you all typically usually see when it talks about mesh networks, Manage. Basically, we're all sitting around each other, we can all connect when we're sitting in this one space. And there's a segment of Manage, which is delay tolerant networks. So delay tolerant networks doesn't require all of us to be connected at one time. It's meant to be intermittent, meaning that people can walk away from the network and they can come back into the network. And the way that works is basically storing forward information. So when you come in contact with users that have your information stored on your device, and when you come in contact opportunistically with somebody else that wants it, you opportunistically pass it. Yes?
Do you carry messages for yourself or for other people as well?
Well, that's a good question. And we'll talk about the two simple routing protocols right here. So basically, everybody propagates their own information, which is usually fine for most users because everybody cares about their own information. Usually in some of these applications, people get hesitant about carrying messages for other people. If you have limited storage and stuff like that, you're like, I don't even want to carry my information. But in this case, you can carry for your user, depending on your routing protocol, you'll carry for others. And then the middleware, that's the middleware, which we'll talk about in a second. But then when connecting, you can also have basic sign-up, which most apps have on Facebook and Twitter. So you don't have to put your information into the app if you don't want to. When there's internet availability, you can log in using your Facebook and Twitter information. So when you're talking to it, if you actually go back, so there, what you just seen is one of the the routing screens. And if you all have the app download, you can kind of see some of the screens. They probably look a little bit better on the device now because those screenshots are from older version of the application. So some of you might have heard of a couple of things that were kind of similar. The Hacker project, which actually worked very similar to what's underlining with SKit, which powers FireChat. But the Hacker project worked on Linux, Android, and basically the way that that project was set up, you needed to root devices. If you're on Apple, and if you work on Android, you need to jailbreak the devices. It runs system-wide, which is different how the SOS middleware, which I'll talk about in a second. It works, so the SOS middleware, which is what powers the application, actually runs for individual applications. So what happens is it's written as a framework, and if an application wants to enable device-to-device connectivity, say for instance, Facebook or Twitter, they basically just conform to the library, which is the middleware itself, and then the application automatically becomes a device-to-device communication network, being able to do all the things that we talked about before. And so it's easy to incorporate more routing schemes. So the schemes that we're going to talk about that's in the SOS middleware are actually written in less than 100 lines of code. Right? So if you think about trying to configure how something routes information, usually you have to get familiar. Some of you might have programmed a simulation environment before you have to learn a whole simulation environment. And so it's really complicated to actually create a routing protocol this long. In SOS middleware, what we've done is abstracted away a lot of the security, a lot of the mechanisms that's needed to establish connectivity. So you only need to worry about how you route information, which is why when researchers or developers want to add routing protocols to the SOS middleware, it makes it very simple for them to do it because they just worry about how information is routed. So this is the SOS middleware that we're talking about. So right now, the way it works, I'll use this running on top of it. But essentially, any mobile application can run on top of it, like Facebook, Twitter, any application that you can think of. And so this is enabled by, as I mentioned, installing it as a framework. And then there's a middleware API there that basically helps you conform, helps your app conform to what's needed and how information is handled in SOS. And the part in light blue are the different routing protocols that can be added. So the reason why this is in light blue is that any researchers, remember that this is a research platform, there are literally thousands of DTN routing protocols that researchers have published papers on. So one of the reasons why this middleware was developed in the first place is that when these researchers were doing this, a lot of times they evaluate the simulations. And of course, if you seen the simulations of somebody who developed a routing protocol, they say, my routing protocol works the best, they can propagate information the best. And then when you put it in a real world situation, it works nothing like how right? Yeah. And so, one of the reasons why we developed this middleware is we said, hey, if you do have the best routing protocol, it's very easy for you to convert your routing protocol into it. So I forgot to mention that this whole application is written in Swift. So you can write your protocol, your routing protocol in Swift right under this middleware, and then essentially you can go into the application Algorithm Social, you can tell the group of users to select that routing protocol, and you can actually collect results and see how that information is being routed. In the real case scenario, say like in Hurricane Rita, say this is being used here, it's not just collecting research results, it's actually propagating information. So situations where you want to evaluate research data, you get people to download it, and see what happens, and then in real world situations you actually get information through. So there's currently 2 routing protocols that you have the application download to receive interest-based routing, which is kind of, this is the name implies, interest. If you follow a user, remember this is very similar to Twitter, if you follow a user, you're interested in the information. So that means that you will receive information that you're interested in, and you'll also forward information from yourself and other people that you're interested in. And the epidemic routing, which is very similar, basically to what most of us know is flooding. Anybody who come in contact with the Algorithm Social application, you push all messages that you have out for those scenarios. So of course, ideally, if you have the optimal wireless characteristics at all times, academic routing will always perform best because you come in contact with everybody and you have enough time to disseminate information. Academic will perform the best, but as we all know, we're doing best networks opportunistic communication is that if you have a lot of people using this, basically you're going to start to have congestion and it won't work.
Sorry, you said it, if the area wants to use broadcast section of it, there will be congestion.
Well, yes, so essentially, so everybody, if you have a ton of nodes or a ton of people, and everybody's broadcasting the information, and broadcasting is in advertising and YouTube is usually okay for the most part, but then if you're broadcasting and you're actually sending full messages, it'll start making it. Right? But this would, basically, the flooding in this case is really DTM flooding. So what you'll see is that in using opportunistic or academic routing would actually perform okay because this is the really common network. It basically only forwards information to use it for. So if people receive the message, they're also not trying to force it out at the same time. So this is, the DTM flooding doesn't necessarily work as a flooding where it doesn't want to perform a little bit better than standard. Yes.
When it comes to like, because if you're say, an example, walking up a city with lots of people and everyone's using it, would there be say like a hierarchy for what messages?
Is there say a hierarchy for messages that are more important than the other, or is it all random, or is there like a time limit, like a counter on it that says this one's been longer than the other, so I'm not going to give importance to this one?
Yes, so that's a good question. So that all depends on your routing protocol, right? So, on your routing protocol, you say that you want to prioritize certain messages. I'll go through actually some examples about what messages might be more important than just a typical message in these scenarios. But that's what a lot of the researchers have come up with, where they say, all right, if a message is just created or a message is old in the network, maybe you should have higher prioritization. If you flag a message a certain way, if a user is more important, or other ways, the way you look at how messages or how nodes store information is by how much battery power a device has. That all depends on your routing protocol. So the cool part about all that is that whatever way you think is best to route, or you want to evaluate, or if you've done something in simulation, you put that scheme into SOS middleware. And then it will route that way. But the two simple protocols don't do that right now. That's it. They have the mechanisms are in SOS to check the battery power that you're going to route, the followers. And so these are basically just to give you some basics about how it works, and then you would add that in. That was a really good question. Yes.
Hi, Corey. Question, can you contrast this with, say, MQTT, which is already a protocol for packetizing and sending data amongst interested subscribers? So MQTT has a hub-sub model where you can subscribe to events, and it has all the prioritization and pretty small packets, and libraries exist for lots of different platforms already, open source. So part of that standards body already. So how does SOS compare to MQTT?
Oh, well, so it's definitely is so the pub sub information here is kind of like a social network, but for like a lot of people are using say MQTT to subscribe to say sensor data, right? And then all of a sudden you subscribe to particular sensors and you receive that information via the cloud. Here, you are using SOS, you're subscribing to a user, and say when you have an internet connection, you might follow that user. But then you're able to receive information by coming in contact with different other users or different devices. And so in this way, it's a lot different from an MQTT. Yeah, this is device-to-device layer level. What's interesting is that a routing protocol that you can implement in SOS will be something that acts like MQTT for the device-to-device level, right? So there's a lot of, I'm not an expert on MQTT at all, but I've used it before. So some of the mechanisms on how they prioritize information, it'll be interesting to see if you write that protocol into SOS middleware, see how it actually works by users coming in contact. But remember that this does not depend on, well, it has some slight dependence, I'll talk about in a second. This doesn't depend on the cloud where QTT is usually set up for people subscribing to sensors all around the world or however it is expressed. Yes.
With FireChat, I saw two limitations that happened. One was the fact that during a time like this, nobody can really download it. And if you download it, you can subscribe to it. So it was kind of like worthless at the moment that Puerto Rico really needed communication, and then we try to get everybody to download FireChat so we can have communication. The second limitation that I noticed with FireChat was that you can send a GPS location, but then it takes a very long time for it to send, and during that time you can't even send no more messages. Is this something, problems that you guys are also dealing with at the moment, or?
So your first one, what was the first thing you said? The
first one is that you can download it through, let's say you put it on a router and then everybody can download it, but then you need to subscribe in order for you to use it. But then if nobody has communication, if there's no internet, there's no service, then how can they utilize FireChat?
Yes, so good one. So,
Well, so I think some part of the idea behind it is that the SOS middleware is a framework. So if you think of it like, let's say this is still a somewhat idealized situation, but the idea is that say Facebook, Twitter, and WhatsApp, and all of these, look at your like top 10 like social network and communication apps. If they all were using this framework or some framework along the lines of that did the same kinds of things, then you would have those apps installed on your phone already, and they would have that framework built in. So when a disaster struck and the network is down, you're not going to download the app. Your apps already have that framework built into it, so that they go, okay, we don't have traditional self-communication anymore. We can communicate using opportunistic communication. Exactly. Yeah. So yeah, instead of being tied to a specific app by it being a framework, then lots of apps can support it.
You think this might get to a platform level where a manufacturer will include it?
yeah, so of course, the question was, would this get to the manufacturer level? Say, for instance, if all Android devices or all Apple devices had this, so that would be ideal, right? That's also hard. We would have a whole different amount of money that has already happened. But yes, so that would be ideal. So, of course, in these cases, the infinity is important. Really, as Agri was talking about, how many users have the framework of the application. Now, one thing is about with Alien Social, the middleware itself, we're talking about Alien Social and users, right? FireChat, I believe, has chat rooms, which you enter a chat room, multiple people are tied to that chat room. In this case, multiple people, different people follow users. Offline, users, when they come in contact, you can see users offline by using Bluetooth communication. You can follow a user even if you don't have internet connectivity, right? And so when you follow a user when you don't have internet connectivity, that means you're also subscribed to that information, which you will be able to receive. Now, when it comes to GPS information, I'm not sure how FireChat was sending. Maybe, to me, I would think it would probably took a while to collect the GPS information or something, or it had to do a combination with the internet to get the GPS accurate.
It takes about 20 minutes for that GPS location to be sent to.
So I wonder. I mean, I'm not sure how FireChat sends GPS stuff. To me, if it's going device to device, if the device is able to collect its own GPS signal, it should be in a sense leading to the next device. If it's sending that GPS location to multiple devices, or say it's propagating it through SMS somehow, then that's probably why I'm thinking it's 20 minutes.
Well, actually, I was testing it mainly just one cell phone to the next one, what's next to me. It takes that long for it to collect data, I guess, and then send it. But the main problem was that as that data is being collected and being sent, you can't send any more messages. So if you're trying to send the GPS location and then send a message of why is it that you need somebody to know where you're at, you can't do that.
So you were offline.
Yeah, this is during the hurricane.
Okay,
Yeah,
and you were trying to
mountains, and we were trying to.
The only thing I can think of, I'm not an expert in GPS, but I know that most smartphones, the way that they typically use, like, I think it's called like network assisted GPS, where they do use some of the satellites, but they depend on like the actual network, whether it's a Wi-Fi or a cell network. So I don't know how the operating system or the application like falls back to like traditional GPS. It may be something along those lines.
Maybe my question though wasn't necessarily to talk about fire trap, but like through Valley, that's it, right?
Yes.
You send GPS locations as well too, right?
Yeah, yes, but that's also something that you can collect GPS information from the sensor. So if I'll leave pads where you save a GPS location, and assuming one, the user enabled it, and two, that the device is able to know it's on the GPS accurately, which is what accurately is talking about. If your phone is saying I need to get GPS by triangulating with the satellite that's closest to me, the wireless access point with what I see GPS wise, then ours could have the same limitation. If it's just using the bare longitude, latitude, whatever GPS gives you, if the phone sees the decimal, it can send it immediately, so that will be quick. So it really just matters. It matters what the phone is using today. Yeah, and data can be sent almost immediately with the device with SOS, but it really matters on what you're using to get the accurate GPS signal. So some of the questions, so there are many questions that came up about routing. So here's an example of one of the routing protocols in Alien Social, which is an interest-based routing. So remember, we said if you're interested in a user, basically your follow or you're subscribed to them, you'll receive that information, right? Or from the MQTT standpoint, you also hear me? If you are subscribed to a sensor or a person, you will see that information at some point. So here, if we think about the current time, so if you think about the original example that we talked about, the disaster hit, some people are segmented, right? So right here, you have Alice, who's going to be the main person of interest here. And really, when this disaster hit, Hurricane Maria hit, she said she's trapped in a building, but she's okay, right? So she says, hey, everyone, I'm okay. I'm just in this particular building, right? And say she's the building right now. And so she posts that message, so that's her newest message, which is message number 5. And in this situation, there's a couple people that's in that building that's around her, say on the same floor. So it's Eric, David, and Bob. When I say around, here we're going to talk about primarily digital communication. So you can think about realistically probably between 1 and 30 meters, right? With walls and everything. But if you look at Bluetooth, it says theoretically it can go over 100 meters, right? But think with walls, let's say realistically with 30 meters. And so here, if the message has, if the device line has F, that means that they're a reporter of the information, means that they follow Alice for interface routing. If they don't have anything, which is Eric here, he's not interested in Alice's information, he won't participate in following. So in this particular case, at this time, at current time now, Bob received the information, which is why you have the R, so he received it. And what happened was David, you see his express, you already have her latest message, right? And so now, and both David and Bob were followers of the information. You also see here at the time, the message before it was forwarded. Bob had message number 2 from Alice. So when he received the update, he received messages 3 through 5, right? So now, some future time, let's say, realistically, maybe 2 hours later. 2 hours later, now some people moved around in the building, some people got out, some people didn't. So now it looks different. So actually, in this case, Bob was actually the person that was able to get out of the building. And say Carol is Alice's sister. So Bob is going around, he's going around looking for his family members, and him and his device comes in contact with Carol, right? Carol has old information from Alice, right, which is message number 1. right? So when this disaster hit, everything that was going on, she knows nothing about what happened to her sister. She's thinking worse, right? And Bob's device comes in contact with Carol, updates her, and she receives the information, and now she knows that her sister is safe and the information was there, right? And this is really how the tower network would work. Depending on the mobility of people, mobile devices, vehicles, whatever it is, to disseminate the information. But as soon as you store the information and you forward it when you have an opportunity, right? And that's really, I don't need anything I said with SOS stands for. The SOS stands for secure opportunistic schemes. So really, when you take advantage of opportunities and this information. So that's really how interest-based routing works. And so you can also think about one of the questions that came up earlier is like, how would you prioritize information? Say in this case, say you have information that kind of came out from some emergency service in this network, basically something that everybody needs to see, right? Like food and water is in this location, right? What you can do is that you can have these types of providers that are already prioritized in the network. So basically, their information can operate on a different routing protocol. Say, for instance, if they have information like this, it might flood or you have to do routing with that information. Everybody sees it, as opposed to just using interest-based routing. So kind of how does this work? So what are all the mechanisms that we're talking about? Well, first, currently it's iOS devices, right? And so iOS devices, which we said that the application is written in Swift, and it leverages the SOS middleware, which is written in Swift as well. With that, you can do Bluetooth, peer-to-peer Wi-Fi, and infrastructure Wi-Fi, all simultaneously to basically maximize the range between devices. And then with it, you can also do the DTN routing, which we talked about in the routing protocols. But you can do different protocols as you so develop under the SOS middleware. And then, say if you do need to operate like a MNA, each device can hold up to 16 connections at one time, right? So if we're all sitting here, immediately we can connect to 16 devices, and then you can store and forward the information. Really, what how DTNs are set up and how this is set up, if you're thinking about this information in the form of tweets, most of the time devices don't stay connected. Really, when it comes to power constraints, you don't want devices staying connected when they don't need to anyway, right? And so here, if a device is able to connect up to 16 at one point in time, but as soon as the messages are exchanged between the devices, and basically that's the connection, and you can tell off of advertising information if it needs to connect again. And then also devices connected to back end of the service. The back end of the service is how most apps work, or really the cloud, when it needs to connect to the cloud. So the cloud here, is what we set up is it's in Node.js, and basically it uses the parse backend, but really simply any backend parses is what we started out with the backend here for your cloud stuff. And then basically it handles when users create an account. So usually there's some limitations I was talking about before. When you download the application, one assumption is when you download the application, you usually have internet. There is other mechanisms that we just talked about where you probably want to enable this when you have users downloading when there is not an internet connection. Basically, when a disaster already hit, you wouldn't have that. But in that case, really you would you can deploy very low-scale servers, which would really be Raspberry Pis, right? And you can have the app sitting on there, and basically you also have the information exchange to set up the credentials there to allow some of these things to happen. But we don't talk about specifically that in these slides. Then really the certificate authority. So I think Agri was mentioning about some of the PKI stuff, really to handle security, which we're going to go into in a little bit of detail on the next slide. We can use PKI techniques, but we use them for SOS and LU, particularly to establish device connectivity. So really what we do is we deploy Node.js code on a server, which again can be a Raspberry Pi device, and we use that device to basically create certificates specifically for our users, and then they can use it to verify each other offline and don't need any internet connectivity. And we'll show you how that's done. So there's one limitation currently that I told you it's not a limitation if you do this on a Raspberry Pi device. But say for instance, as a user, you download the application. There's a one-time infrastructure requirement, right? Which is when you download the application, usually that's when the user creates their account. There we establish all the security credentials and the certificates needed, and then everybody can operate offline. So that way that works is we'll look at two people's devices that both go through the same thing, Alice and Bob. Right, so when they download the application, the device creates a public key, private key pair, which here is actually the curve keys. And then they take these keys and they create a certificate signing request. They take the certificate signing request and they send that to the cloud, or like I said, it can be a Raspberry Pi device that's needed. When they send that to the cloud, which is back-end service, the back-end service sends it to the certificate authority. And the certificate authority, this is dedicated to the certificate authority, turns that into a specific certificate and also gives the root certificate for that certificate authority, which I'll say CA instead of certificate authority for the rest of the world. But so when they have the back end of the service, basically gives that back to all devices, and now these devices can operate off the grid, essentially for the lifespan certificate. So now they can go around verifying other online social users without ever seeing them before offline and talking about online. So here, we're going to the example that we've been using the whole time that Alice, Bob, trying to get information to Carol, is that here's Solid Blue. So you have Alice advertising information. Advertising, you can think about this in this Bluetooth, it's your broadcasting information. So basically everybody can see it. And then she comes in contact with Bob, which is Bluetooth contact. And basically Bob sees that that Alice has information that he's interested in. So he says, all right, I want to connect with you. And he does that by broadcasting that information as well. And then once Alex accepts the invitation, they exchange those certificates that they already have, their own certificates. And once they do that, they extract out the public key for the certificates. One thing that's in that certificate is that also embedded is the user ID, the unique ID for each particular user. Right? So people know what user they follow. And so when you follow a user, you say, I follow a particular user or a particular source of information with this user ID. And so now they extract that information out. So they, even though they don't have internet connectivity, they know who they follow, right? And so they can say, I know that user. And now they establish a secure connection between each other. So now, in this instance, sometimes information doesn't need to be secure in these scenarios, but if they do, now they can send the information device to device and nobody else knows what's going on. Then Alice gathers the information she needs to send. In this case, it was message 335 to give to Bob, and then sends that information to Bob. Bob uses the certificate that he has on his device to decrypt that information, verify that it actually came from Alice with that user ID, and then says, all right, now I have Alice's tweets, right? And so that's how information is sent from person to person. Now let's kind of look at how a forwarder is selected. So in that same case, if you look through, most of this is basically the same dissemination that has happened all the way up until where you see the unlock. But the only thing here is that, say, Bob is becoming a forwarder, which is an example we did, right? So he's going to forward information on behalf of Alice. What he does is that certificate that he just got from Alice, he just saves it to his device, right? So now he saves it to his device, and he can use that to give to other users in the future when he comes in device to device range. So let's see how it works. So now it's going to be a little bit uglier, but if you got past the first two slides, this should go okay. So Bob now comes in contact with Carol, which remember that Carol was Alice's sister in the example that we used. So when he comes in contact with Carol, they do the same broadcasting information, but what he does is when he sends his certificate to Carol, well, actually, let me rewind for 1 second. So when Bob is walking around his device when he's broadcasting, he says, I'm an information carrier for myself. This is broadcast information. And I'm also a forwarder of Alice's information, right? Because he remember he became a forwarder. So now when these devices, when Carol says, oh, you have Alice's information, this is her device saying this. I'm subscribed to the information I want to receive. So now when they are about to, when Carol is about to receive Alice's information from Bob, she receives Bob's certificate, and then she also receives Carol. Now somebody might think, well, what if Bob compromised or he modified Carol's certificate? Well, remember, Carol has the root certificate from the CA, right? So she knows that this comes from Aliu, if that ticket, if that certificate was modified, automatically it would turn back, it would turn on garbage. Carol will say that you don't really have Alice's information, so stop communicating. So now, when she receives Carol's the certificate that came from Carol through Bob, she pulls out that user ID, which she already knows herself, right? She knows that Carol, she knows who she follows. She knows that she follows her sister. So she knows her unique user ID. Since the certificate checked out, I can trust in that user ID. So now, Bob gets together all the information he got from Alice. He sends that information to Carol, and now Carol uses that certificate that she just got from Bob to verify that information came from her. Now, mind you, now this allows you to do a one-to-many relationship with one person with many devices, right? This device that communicated with Bob from Alice, Carol might have never seen this device before. Because her unique identifiers in that certificate, she can say that I know that they came from Alice. It doesn't matter what device, it doesn't matter if I've never seen a certificate before, right? So basically, that's all what happens there, and that's what happens with secure systems. Now, mind you, with that, with securing, all the security that we talked about is all elliptic curve. So a lot of times, security schemes online is using RSA security, and here, elliptic curve is like one of the new standards. It's like what Apple is using to secure like your fingerprint information in your phone. Probably using for the face stuff, so it's super secure. And this is using 256 bit keys here. Right. So, example. So, on collecting results using Knowledge Social. And so here, here is a sample of when I was at University of Florida in graduate school. 10 users that were using the application. So we had, of course, here you need some type of density. We had like 80-something users download the application that was all over the US. There was about 10 users who were probably like all my friends and people that I knew directly. Right? And so what happens is 10 people downloaded it and they were using it consistently for over 7 minutes. Right? So here, hopefully this speaker doesn't go off. If you see, so to give you some perspective, this is the city of Gainesville, Florida. So this is the University of Florida in the middle, and this is Gainesville Airport. So this is a large part, this is a decent sized city, right? Blue is when a user created a message, and they created a message, and they created it at different times. So they had a GPS basically enabled on their phone, and they were going all around the city, and they're generating their own information. So a lot of times you might see in simulations, people say generate with some random process a message. These are people actually writing messages going around the city. Red is when at least two out social users came in contact and their devices exchange information, right? So you've seen that just happen all over the city, but you also see between these 10 devices. So to give you some perspective, this is 11 kilometers by 8 kilometers map, right? So this is huge. And you see what happens is that the red exchanges between people kind of happen in a lot of similar places. Message everywhere. But dissemination happened where here, a lot of this was me, this is probably like the engineering building, right? And then here, these are graduate dorms that were all campus, right? And so you see that exchanges happen in certain places. Remember, this is 10 people in a large space, so it's very low density. And so during that time, over the 7 days, 259 groups were created. And then what happened was, remember, this is a public subscribe system. So there's more messages are going to go out than actually create. 796 messages were sent using one hop. Right, so you see that's me sending my message to the next user. But then you also see 167 messages were sent by more than one hop. So you see that there was actually routing going on in this scenario. So when it came to relationships, so a lot of times when you look at graphs like this, you think about is this how the network's connected? Not necessarily so. So the routing that was used here was interest-based routing. So it's very important to know how the users follow each other, right? Who follows who, because that dictates how the routing protocol disseminates information. But it doesn't necessarily say that's how it's going to be disseminated. So here, between the 10 nodes, the average shortest path between a node, meaning friendship-wise, is about 1.3, so almost everybody knew each other. Where the density was about 64% of the possible routes that were covered. So you see that in short, the radius, which is basically the center nodes in this network, is nodes 6 and 7. They both are one hop away from every user when it comes to friendship. So I'll tell you how that works. 6 is probably me, and then because all my friends downloaded it, my roommate was like a super popular person, so he was the other person. So what happened is when everybody put in the application, they all kind of say, oh, who do I know that's using this application? I'm automatically going to follow. And so, of course, it would write the biggest pushes of information that goes out on any network. And so, to give you some of the results that kind of came out of this, was interesting to see is that 25% of the messages were delivered in less than an hour, right? So that's actually really good for this case, especially since it's a realistic case where people are actually going to sleep. Most but so maybe they weren't getting too much sleep. But then when you have something that you look at simulation results of things that happen in these scenarios, you'll see that they'll simulate parts of environments, but you're not simulating usually 8 hours of sleep, right? With no movement. And movement is very important in these scenarios. And then you see 43% of the messages were delivered within 24 hours. And you start seeing something that looks more realistic, where with this low density, 90% of the messages were transmitted over 94 hours, right? So you have more mobility, more nodes, of course, you'll get more information. Then when it came to the message delivery, so remember this is all dependent on people decide who they subscribe to. So not everybody wants every message, right? And so 30% of the subscriptions had 80% delivery rate over this 7-day span. And then 50% of the subscription had 70%. So you kind of see how information was propagated between the 10 nodes using Outlook Social. So to give you more perspective, interest-based, what we just talked about, the 10 nodes, the transmission range, I said it was between 5 and 50 meters, right? Now, there's really no good way to quantify this because remember I told you Outlook uses peer-to-peer Bluetooth, peer-to-peer Wi-Fi, infrastructure Wi-Fi. So we don't really know the range. It depends on how the users, where they were at, but they're going between those three. But let's say it's between 5 and 50 meters. When people typically do simulations, these are simulation papers that are here. They'll have 50 nodes and then they'll even simulate up to like 200 meter communication range. And then you see that their area, which is very important here, they're typically using very small areas. Really, when you see simulation environments, and you see results in these papers, they're typically creating very high dense environments to evaluate their routing protocols. And when you do that, you still might be routing, but you need to be able to evaluate some realistic cases how your routing protocol works. So some future research, I know some of you downloaded the applications in case you wanted to download it again, see the camera, we'll give you another opportunity to download it if you want to. But some of the future work, so some of the questions that kind of came up, SOS middleware. In the notes was another application that we're looking at before. When it comes to maybe using things for when children go missing, you can have like a Bluetooth tag on them and use other people to kind of crowdsource where that child might be at. Usually, when you think about, say, a kidnapper taking a child or something, they usually let them keep their toy because they want them to be quiet or their jacket on them. And if they do that, you can use that information to use things like this to triangulate. But then if you think about wanting to create density, you have Facebook, Twitter, Instagram, any social media basically adopt to the SOS middleware under it. They already have tons of users, and you basically acquire that density once you do that. And so that was part of the chart that we talked about. But then some of the other things, really when it comes to delay tolerant networking, using basically improving more routing. So right, many questions came up about routing, adding more routing protocols. Basically, one of the things that SOS does, and that Aggregate is looking into as well, is basically how operating systems play a major role in prohibiting device-to-device communication. So there's a lot of tricks that we can talk about that we do in on iOS to basically get back resources. So what happens is, I'll give you an example. Or actually, let me just try to give you an example for quicker, which is kind of switched up. Or actually, I'll give you an example in a second. But in this scenario too, also disaster relief applications, which we're talking about today, basically how do you create applications for modifying, I'll be able to do that, creating the low-cost smart city. So that, like, for instance, we said when you look at cities like San Diego, we're talking about smart city, they cost billions of dollars to change your city into a smart city. Right? It's a lot of money. When you look at cities that might not have that much money to spend, but they have people with mobile devices, you can start actually, the sensors that they're using to say collect weather data, everything else is usually very cheap, right? So you put those sensors out, you just pay to put those sensors out, you have users contributing to actually when they walk by, and maybe you incentivize say the bus passes or whatever, and you they collect the information, you disseminate it to your central source agents, the government, wherever you want to send it, and you receive it with some delay. You think about weather data. Most people don't need weather data in real time, right? And so you can basically turn any city into a smart city. Another quick way that we're looking into to add density is when we're talking about Raspberry Pi as a distributed authority. You can also use that as the router of some information. So if you strategically, you understand the layout of your city, you can put these devices that are just Bluetooth equipped in the middle or in certain places, and you use that to increase density. And then also, of course, using this on public transportation like buses, post trucks, etc. And then mobile health applications, which I'll talk about on the next slide. So one thing that we're also looking into when it comes to using this in a mobile health settings is that in a lot of rural areas, there's data that shows that people that use these are able to do electronic patient monitoring on applications. They've actually been increasing the lifespans, the health of patients that's actually using these, whether it comes to Fitbit or whatever devices. But of course, in rural areas or places that lack internet, most of these places have to become stationary when it comes to improvements in those areas. So what you can do is you can have sensors that are on a user, or you can also receive input that they touching on the application, and then you use, say, the SOS middleware to disseminate information using other users on public transportation in the city, and basically I mentioned that information gets to the doctor, right? And so now you have this delay tolerant patient monitoring, where here the first figure shows, right, this is kind of what the network looks like. The first point where you have connections between some of the devices, and then people move, you have some mobility, and then you get the second scenario where maybe some people get internet, they don't get internet, and then the information eventually gets to the doctor, right? And so we're looking at one application specifically here, which is called My Patient Vitals. Adam, do you want to say anything about that application, or you think that was that?
Yeah.
Okay. Yeah. So another case too also is when it comes to these low-cost smart cities in these scenarios, say when there are natural disasters, start using drones to kind of help assist here. So here, this is a grid layout to kind of show this in a very simple way. But if you have source nodes, which basically nodes that create information, which are really here thinking about set buildings. And so the source nodes are in green, which are the green circles. And then you have red nodes, which are destination nodes, right? And then yellow nodes are not either source or destination, but they just help route information. So these are stationary areas in different buildings. And really, no building is really generating information, but say it's a highly populated building where people pass through a lot, say something that's a police source and a disaster area. And what happens is you have routes which are not necessarily connected routes or a straight connection, but basically you have people that travel more one direction than the other, right? So if one is red, basically they have a low probability of receiving information, or low here, say anything lower than 80%. And green, anything higher than 80%. So you have these routes, or you have good routes and bad routes, but basically people across the whole city want to receive information. So what you can do is you can deploy drones, which if is very strategically where you say, you put a drone here, which is one of the bad routes, you can basically improve communication. So what's the most optimal place to tell the drone to fly? Which is another thing that we're looking at as well, kind of improve connectivity. So, so to give you some more information, the lab, our research lab is at Agri is currently PhD on. Purdue, we just started at UK. We currently have 5 PhD students, 1 master's student, and 1 undergrad. And you know, of course, looking for students UK. If any of you are looking for a graduate school for a master's or PhD, in the fall, we're actually planning a visit where we're paying for everything for the fly out for looking into graduate school. If you go to this link here, which is a different link than I'll grab, I promise. Right? Not trying to get everybody yellow on me, but if you go to this link, it'll take you to a Google form to fill out. If you fill out that Google form, basically, and around the end of November, we're setting up, we're going to have a visit. Like I said, everything is covered. One quick thing, which we're planning to have, you see the basketball team, if you guys don't know about UK, it's the greatest basketball team in school, whatever. And so if you want to come see the team, you always have a great team every year. But what we're doing with this visit is that we're actually going to have tickets to the basketball game, to one of the basketball games this fall. So if you don't want to go to basketball, you want to go to games, sign up. If you want to go to graduate school and you want to go to the game, go to the link, and then we'll try to get you added to the list for that. So with that, questions? Well, I guess I'll take questions if I ask you all questions. We still have time, right?
Yeah.
Okay. Yes, was there a question? Yes.
So, what would it take to get the SOS middleware running on that?
Good question.
Yeah, that's it's something we've talked about and looked into. I think mostly effort. One of the things that we do take advantage of on iOS is the what's the framework called? Yeah, there's multi-peer connectivity, which is it's a wireless framework that allows for easy communication between devices. As far as I know, it's been a little bit stuff, but there wasn't a matching framework on Android that allowed the same.
Peer-to-peer meshing in Android is not permitted in the device.
There you go. Yeah.
I think, and also, so
It can't be peer-to-peer. You have to mesh it.
well, I think they have something similar to multi-peer connectivity. I forgot what it's called. I know. So the thing is, here, so the great part that we have here is basically any wireless framework that's on the device you can write to. So specifically, if you wanted to create this specifically for Bluetooth, so if you create a part there, a framework there, then you can do Bluetooth communication. And I think it's using multi-peer connectivity, which we currently use, to communicate with the Android device, and then you have tried, it failed. So say, for example, FireChat started off on iOS and was using, part of this stuff was using multi-peer connectivity. And then they switched to, they got a lot of money and they started writing specifically, they write their own stuff, and then even the iOS to Android communication is still kind of new, right? And so, yes.
Just had a question about the battery consumption.
Oh, yeah, all right, so we'll get to that in a second. So the part that Agri mentioned is a lot of legwork. So when we have a decent sized lab now too, but even the efforts, we don't even have enough time and effort to try to, it is a lot of code in the middleware. So we just say, writing a routing protocol is very small, but it's because we handle a lot in the middleware itself. And so really with that, just because we started out, I had a bunch of iOS devices, I like iOS more. On Pro iOS, and then Agri, which is a very special type of person, which worked at Google, but it was the iOS person at Google, right? And so, so you know, we have I kind of bias the lab sometimes, but it's really, you can write a version of SOS middleware, and I have been approached by like some potential collaborators. The only thing is that this hasn't been the direction we look forward to, just because it's a lot of effort. Yes. So your question, battery power.
Yeah, but battery, how does the SMS go word out there? Like, always broadcasting out, I can imagine that consumes a lot of battery.
Yeah, so one thing is I don't have the results and actually don't show it for utility. So when I showed the results of what happened at the University of Florida, that was the very first version of the application. And that's also what I was trying to graduate, right? And so I said it to say the battery power was terrible. And my friends were complaining, like, you're killing my phone. I said, yeah, but I can graduate. and so
there's work to be done in terms of like just optimizing the battery.
Well, there's always more work to be done. So that was 2015. There's been a lot of work done. So battery life on SOS actually is really good now.
Can you talk a little bit about what your approach would be in terms of like how you save battery like in your context?
Yes. Actually, we covered two things. One slide. 1 at 10.
It's actually a lower battery consumption as years as past by, so it's like a lower frequency now as it's ever been.
Okay.
But the only things that
So that works out better from the manufacturer's side.
But if only one person is relaying the messages, then that battery's gonna get drained really quick, I'm sure.
Oh, yeah. So this one, this is a little bit outdated, so there's been some updates to this. So when it comes to, so of course there's Bluetooth itself being low power. And it's really when you advertise them. So the advertising part is usually not too bad. Well, first of all, I actually really want to. Most operating systems are going to restrict, Android and iOS are going to restrict what you can do. So if your app, first of all, is attempting to kill a lot of battery, the operating system is cut you off. So that's one thing. One simple way that they do that in iOS, and I'm sure Android has something similar. Android knows a lot more about Android than I do. I honestly don't look at Android at all. This is me. But one thing that Apple does is when you have your app, and this is actually something that's very important research-wise, is looking into average repentance. When you open up your app, say you open up Facebook, you get 100% resources on your device, right? And so iOS will say, oh, the user is using your app, you can do whatever you want for the most part, as long as the user is moving, right? What happens is when you go away from your app, so you get a phone call, you go into the background, one, you probably got a notification on your iOS device before it says, this app wants to use your device in the background, and you allow it, right? So the user, you have to allow it. Two, even if the user allows it, iOS gives you about, what, 2 to 3 minutes, I think, operating?
Yeah, that's you get 2 to 3 minutes. If you try to keep going past that time, then the operating system will kill your application.
Yeah, so that's if you're trying to do network connectivity. So that's one way the operating system will attempt to limit your battery. Now, there's two problems with that. One, battery. If you think about this again, depending on how popular your app, I'll use social, not Facebook, right? And so people are not going to have I'll use social open, walking around all the time to be able to broadcast and pass information to users. So how do you get around this? Well, one way, one reason why I like about Bluetooth, the way that well, first of all, if you're an Android/Linux user and you use the Bluetooth stack Bluetooth before, there's no I don't use that. But basically, the BlueStack is terrible at being up to date on what you can do with Bluetooth. If you recall that iOS was one of the first people to actually move to Bluetooth 4, they did it in 2012 with that iPhone 4S actually. Right, so they did it, they one of the first. And iOS developers, Apple themselves have done a really good job when it comes to managing how you transmit. I think they actually have the highest transmission rate on the Bluetooth. They get closer to the theoretical iOS. So what happens is when you're on iOS devices, you can actually subscribe to Bluetooth to say that I want to use this even when my app is not in the foreground, and you can see small bits of information broadcast. That's one of the things that we attempt to show here. Is that when you're in the foreground in green, you get 100% resources. But then when you're in the background, when you get moved to the background, you subscribe to Bluetooth, where before we used to subscribe to iBeacon, but iBeacon, which is really Bluetooth 4 in combination with some other stuff, we don't use that anymore because of the limitations. Apple's been more strict on iBeacon, but you can just use Bluetooth in itself, and you can say, if somebody's advertising some information that has this particular UID, I need you to give me some time back on the operating system, right? And so those are the ways that we kind of mitigate boundary crowding. And also, you still need users to play in, and this is how you influence the operating system. One way we're currently influencing the operating system is that if your app is in the background and you come by a user and that user might be your friend or you receive some new information, we trigger a local notification. This doesn't use the internet, we trigger it directly on the device. Hey, you pass by and receive some new information, you probably want to see what that is. Right? From a user standpoint, they want to see what it is. And this goes into the UI UX stuff. They see that they receive new information. You don't get really said, I need 100% resources, right? So there's different tricks you can do in to where if you start understanding how these things are going to play, then you can start influencing the operating system developers, iOS and Android. This is how you play with device-to-device communication if you want these enabled on your devices. So those are like some of the things that Apple is actually implementing about.
Sorry that I don't want to get a bit later over covered. But then, so this is also about you depicting to leverage IP, and how specifically then, in which context would the IP come into play when I'm following the flow diagram here, when the notification to the user is not sufficient to cause that app to go back to the program.
So one thing on iBeacon here, iBeacon replaced iBeacon with Bluetooth 4, and what part was you talking about?
So you were mentioning here that getting around the background with the internal notification. So is that part of the iBeacon program?
Oh, no. So what happens is, when you receive the information, say some broadcast information from Bluetooth, what happens is the notification you generate a local notification on the device. So what we did is once we subscribe to say a specific UID in Bluetooth, iOS will say, you said you subscribe to this, you would have a notification. And then what we do is on that is we send a notification to the user inside the application. But not your typical cloud push notification, a local notification. It looks the same.
And when you touch it, then it brings the app to the foreground, and then you can do all the types of stuff.
Exactly.
So it's a lower layer notification, just because if you're playing on the side of the user, you're betting on that when this is a little notification, will put that, so it'll bring the app to the foreground, and then the actual message will over there.
Exactly. So in these situations, we think about when the natural disaster, say like Hurricane Maria, if you see a notification like you received something from Alice, which is the case example that we gave earlier, from Alice, who is your sister, and you have all information, you're going to open it up immediately. Now what happens is when people, say the case of my University of Florida example, people always have internet and they use Twitter or Facebook more, they might not open up when they see that application. But there's different, that's why it gets weird because it's like thinking about device-to-device wireless communication, operating systems, and then we're like, wait, you have to pay attention to UI, UX stuff. What influences, what plays on your site that they basically trigger them to give you 100% resources. Any more questions? So I know I agree. I know there were some things that you wanted to ask.
I guess we're kind of wondering, I guess based on like the presentation, the kinds of things that you all could see yourselves, like do you see yourselves using this, or like would you build on Alu, like what kinds of ideas, things that you guys are thinking about doing, like just trying to gauge interest and figure out kind of like what are the things you guys are thinking about doing. And if SOS Builder or like even how you build it would be able to work for doing any of those things.
Yeah, like there needs to be, like what would be needed in a social network like this during the time of natural disaster? What features would need to be added? What things, those are things that we can talk about, you can work on during the hackathon.
Yeah.
To say like, oh, well, we need to be alerted to this, or we need something to give us information like this. Currently, I guess we should bring up some of the limitations. I'll use social right now, you're just 140 character messages. Kind of like Twitter, we're limited like that, because we're making like Twitter, but if you need to send more data, right, of course that brings in different questions, but maybe it's not just data, maybe there's other information that we're unaware of that's needed in these scenarios, which is what Agri is talking about. Like, tell us what you think is needed in your ideal social network or natural disaster.
Well, it seems like one of the major problems that we had in Puerto Rico when the hurricane hit was that most of the places that started getting some type of service are places where they're safe, where people are economically well. But ones that actually didn't, and still actually don't have any communication, are the people that can't afford an iPhone. So that's why to me and to many people that don't have any communication, it's really important to have Android, to have it in Android, because these people in the mountains don't have iPhones, and therefore they won't be able to actually benefit from this situation.
Okay. So I was telling my friends here when the disaster happened, I built like a little Raspberry Pi that provided an access point, exposed a website, so people, I walked with my backpack with a Raspberry Pi in my back. I would walk to people's homes. They would connect to my Wi-Fi, access a captive portal on the Raspberry Pi, and upload whatever. They would send a message there, and then I would relay it. When I got to a backhaul or I got connection, I would upload them to a cloud. I'm thinking that if you could. What about if you could pair, if you could deploy the protocol in the Raspberry Pi and leverage the like an actual website, since people probably won't have the app or they can't download it there, but you could have like the SOS protocol in the Raspberry Pi. That's something you can deploy and you can cover a lot of people. I don't know, there's something along that line. I think like in practice, it was actually pretty easy for people just to connect to the Wi-Fi, put a little URL, and have a little UI to send a message to somebody. I would just capture the phone they wanted to send to and a message, and I would just use Twilio to send the SMS when I got internet connection.
So that's a good point. That's actually really cool, actually. So one thing is, if you, one of the things we're talking about communicating with Raspberry Pis is that, so iOS devices currently can use SOS middleware, but if it runs into a device that doesn't have SOS middleware, which would be, say, the Raspberry Pi backpack at this time, right? You could basically just use Bluetooth 5, Bluetooth 4 to communicate with that, and as soon as the device receives it, it can now also use that, and use regular Bluetooth, and it can use SOS middleware to disseminate. One advantage that SOS has, of course, is that it has some routing capability, so you might not be able to do the same routing capabilities with that same information when it comes to device to device.
But you can deploy the SOS in the Raspberry Pi and still have the same routing capabilities as a phone would have, as an iOS phone? That's the part I don't understand.
So you could, so that goes into what we're talking about before, like porting to Android. Okay. You would have to port the SOS. Sure.
Okay, I see.
But yeah, of course, if you ported it, it would be able to do some of this stuff.
You guys, we have a lot of public clinics, we have a lot of other so even with iOS, even with iOS, we'll have a lot of other personnel. So I think from what Joel is saying, you can envision sort of a hybrid architecture where you're going to have public clinics, doctors there, you're going to have a bunch of other personnel that have iOS phones, and they could be using SOS middleware, and then they could be, you could basically maybe create some sort of gateway software that then talks to other captives.
So my point is kind of like the meta thing is that maybe there's something, just thinking off the top of my head, maybe there's some way you could leverage like I did, like mobile websites and have some hybrid setup so you can take care of people who don't have the SOS middleware installed in an application. I don't know, maybe there's something to explore.
So similar exploring exactly what we're saying, with FireChat, we were downloading it right here on hotspot. We velcro it to a drone, and we just throw it up in the sky, and that's what we gave FireChat to the people. But then the limitation was that you have to then subscribe to FireChat, and then that was it. Dreams crashed, you know. But I guess utilizing the same concept when you guys.
Yeah. So that's where it is. It's definitely possible. More additional things need to be set up. So I guess I didn't realize when I didn't realize that you first said subscribing to FireChat. You're literally talking about signing up for FireChat, right?
Yes.
Yes. So, so I guess in full disclosure, currently the stuff that we talked about would have the limitation, that same limitation, right? So if you don't sign, well, you can download it. If you don't sign up when you have connection. Now the difference is in some of these areas, like say for instance, there was times where you were walking through the area and you're collecting information from the backpack. We can set up a different Node.js deployment that can handle signups. So basically, your backpack helps sign up stuff. So that is possible. That part is not set up. That's probably going to happen on the project further.
Well, I say honestly, that's fundamentally like a big part of what, like I'd say one of the things I want to look into with my research is like when you don't, like I said, when you don't have that infrastructure, how do you communicate between people? How do you do it securely? How do you like verify that? Like all of those things kind of encompass like that problem is like one of the problems I would like to solve, like having a solution.
So have you say like a guest? I mean, if anyone's been in the chat room, there's always that little guest. Then you create your person, random guy 69 or whatever it is. I'll let you just go by it. Whoever the guest is calling, that you have a question. Didn't say joining a.
Well, it's not. So it's not out of the question. So what happens is one limitation here, which I guess there is some coding that actually has been developed for this. Like, so one, remember we talked about certificate authorities when you're verifying security. Is one that user ID. One needs to be unique. Now, there's UUID generators, and I don't know the formula of how they calculate uniqueness, but they have some formula to do this. So one, that UUID generator has to be unique. Two, the other problem with just being a guest is in this type of social network, this is a publish-subscribe social network. So basically, people receive information from you when they subscribe or when they care about it, right? So when you sign up as a guest and you have a new username or whatever, and nobody knows that name, then people are not going to want to receive that information, right? So say you're new. So what happens is, the natural disaster hits, you just generate it, you sign up with a new application. People might not know who you are as a user. Now, that's pretty easy on the cloud because you can say search the cloud for all users. I know that person, I know that picture. And this way, it kind of gets very hard to verify who that person is. So it's possible. One is as long as you can tell, you can verify the uniqueness of the user ID. And then two, now you need to get other people to still know about that unique ID because they need to subscribe to you.
There's a software called Secure Scuttlebutt. Have you heard?
Is this secure web?
Secure Scuttlebutt.
Secure Scuttlebutt.
Scuttlebutt. Yeah.
Scuttlebutt. No, I haven't heard of it.
So it gets around some of these problems. You can connect to people in your same local area network and just subscribe to them directly. And it doesn't use a central authority. So as long as you use your public key as your identifier, as long as the public keys are unique in your social circle, it doesn't care.
Okay, but there's probably some, so because we talked about some of these types of things, right? I don't know if you want to say like, so there's pros and cons to that setup, of course.
Yeah, I'd have to see. I'd have to look at it. It sounds interesting. I'd have to look and see what they were.
The other thing it does is that it carries gossip for your friends' friends, and their friends. Right? So it goes like 3 layers deep.
Yeah. So okay. So basically, they're verifying trust over friendships. So if I follow you and you follow this person, we have more trust, then there's a lower layer of trust between the further you go out.
Yeah.
And so, yeah, so there's definitely, we're talking about some of those mechanisms and how they can be used and maybe how to use these in these types of applications. There's definitely a way.
It's cool because it'll bootstrap from like no connectivity, right? I mean, as long as you you can see somebody locally, then you can start up a community with no signs.
Yeah, that's kind of like some of the, we're talking about, maybe you use blockchain to enforce trust that way.
I can quickly consider that.
More questions? Of course, too, I mean, feel free to, what do you think needs to be in a social networking application like this? Whether it comes to maybe, I mean, one of the things to be, well, we don't think security is needed at all, right? If we're trying to get information, if we can get more information through with no security, then people will be fine with it.
Is that okay? Is that possible?
Well, of course it's possible. I mean, it matters what's needed in the application. Security is not, so of course there's some performance issue here when devices are walking by and verifying each other's in this information. Or maybe there's, the other thing is there might be certain types of information that we don't care if it's secure, right? So there's a, but
No, I was gonna say, that was sort of around that, it will depend, on who's communicating on that information. I'm guessing you just wanna ask somebody in the community if they've got salt or no, who cares?
If you want to say you're safe.
You wanna say you're safe, communicating just general information, or
You're asking for help.
Right,
Help,
sure.
you know,
You don't want anything
you
right
to have a secure line or anything like that. You're asking for help. It's like 911. You don't need a service for that. Any phone, just pick it up, dial 911, and we'll be able to communicate with the person.
Right.
It's the application of it.
If you scream, I'm drowning, you're screaming, you don't care about the people here. That's why you're screaming.
Yeah, the actual application definitely matters, like whether like having security all the time is nice and ideal, but there are situations where, yeah, if I can communicate, I don't care if it's secure or not.
If you're upfront about it and you disclose it, it shouldn't be a problem.
Yeah.
But I wonder, so the thing is, the reason why it gets really interesting, I'm trying to think what was the name of this movie. There was a movie that basically, everything had been like destroyed for years. There's only a few people still alive. What happened is people got real particular about where to talk about food, water, or having gas, because what happens is people are trying to figure out where that person is, and then when the text all that first, if it's something that you assume like it's something that you right now, and you assume that this case is going to be temporary, right? But temporary can have some time span on it. And it might be okay, but then it might get into scenarios where it's like, all right, maybe that information is not public, and you have to get part of it. Also, it can be like the boy cried wolf, right? So somebody can say, I guess I'm bringing a Craigslist example, right? So people are going to Craigslist saying that they were selling a new PlayStation at the time. And really, somebody will come and say, oh yeah, I'm gonna pay this $600 for the PlayStation, and come to the house and rob that person, right? And so it gets interesting on how you do security. What happens in this case, you're able to verify, and of course, we're talking about volume social. If you follow a user that you already know is that user, once you receive information, it's verified that you got the information from an official authority or whatever it is, it's easier. So it's like pros and cons for both ways.
I can see that, and definitely after like what happened here after the hurricane, a lot of gangs started popping up and just stealing stuff and assaulting people because there was no security, you know. So definitely they would go, yeah, this guy has the stuff, going to his house and take his gas or whatever.
How about a hybrid? Like radios used to be before, like you can send like public information, but if you want to actually speak to the person, you can go to a secure line, for example.
Yeah, I think so. These are the things, of course, that is going to discuss now, like how to enable disable features. So one thing is, of course, no security. We've done a lot to bootstrap security in this area. You couldn't remove it for certain things. Like one thing with the police security that you mentioned, like anybody can call 911, but then they also have some hierarchy of, well, they're sending people, enforcers, right, to come, no matter what, you call 911, you hang up, usually they're gonna show up, right? So when they show up, those people are prepared to show up to where, for good or bad, right? Where, in this case, in the case that we're talking about, we don't have an enforcer to say, all right, are you, well, there could be ways. So you could use, so one thing you could do is crowdsourcing, right? So if you say, if somebody sends out some public information and
people are flagging that information, like, kind of like how, what's the program with Stack Overflow? People say, oh, that was a good comment, right? So thumbs up, yeah, thumbs up, thumbs down. And you can start using the community or people that see that to say that this information is true, or it's good, yeah. And I think the thing is with that, you just have to have enough. I'm pretty sure there's research that's out of the scope, my knowledge, what information is enough to verify something on the trust system.
So when if you're talking about the blockchain implementation, so that would be a case of a validation game where you would stake some value against what you are proposing, and it would get challenged with more stake. But there's a lot of mechanisms in blockchain just to validate trustlessly that this data, either you put your reputation at stake or you put money at stake.
I guess to summarize, really what we're saying is, the problem when a disaster happens is that we can't sign up. We don't have internet already at that point. So people will need something to just download, regardless whether it's an iPhone or an Android, and immediately communicate.
Proactive and design around it.
There's two approaches to that. One of the things that was commonly seen down there right after the hurricane is, especially with first responders who were not familiar with Puerto Rico and the geography here.
One of the problems that a lot of first responders who wasn't familiar with Puerto Rico that came down here from the mainland had was trying to navigate around the island. Google Maps obviously requires on a data signal, and you try to navigate, nothing was going to happen. Now, as you were mentioning, trying to get the data when it's needed, that's a problem. And like you were mentioning, being proactive is another method of handling that. Now, yeah, we got a bus sketch when we initially got on shore, but then we started depositing, hey, you got to cache those maps offline before you come down here. Don't even show up without those cache and the translator app and the language back cache. You do both of those. So definitely, I think it could open is more of a issue with actually, the human element, making sure that they have this installed ahead of time. So, I mean, in a way, that's kind of a marketing issue, if you will.
In theory, out of curiosity, I told the space out for telecommunications funds.
Would it be possible to use someone's own telephone number as a unique identifier, or would that be stored on the local device, or is that something that you would have to actually?
I can answer that. Well, I looked into this, and at least Google's research, they conclude that that's not a good way to identify. But I don't know, but that's what I did. What I did, like, it was my very simple deployment. It used the as the unique identifier. But researching more into it, I saw Google's research that you couldn't rely on it. People have different phones, all that type of stuff.
But you wouldn't know what I wonder. So you know what you're talking about. I haven't seen it. I haven't seen that. But I'm not saying this, but I wonder if Google is the one that messed that up. Because if you think about when Google Voice, when they start being when you create numbers, because what happened, it wasn't, at first it was a lot harder to get a phone number. That was easy to generate and get a phone number. And a lot of that happened with the original Google Voice. I wonder if Google did the research afterwards, like, and I'm not saying it happens, it was maybe they conclude like, oh man, maybe we messed this up, or maybe it was I want to is that you can identify it. Aggie, what are you doing over there? So, but no, seriously, I bet that to me, now anybody can get multiple phone numbers at any point. I bet you when it was only carriers and handing out cell phone numbers, it was more you. Only one person you can tie to one phone. So I guess one thing maybe I should put up the link. So if you guys, so the one in development, if you guys are interested in using this for the hackathon, if you go there, it's just you put in your name and your email address, I think you answer like 2 questions. What we'll do is we'll add you to the GitHub on the project, because right now it's still under priority mode, but you guys can have access to it. You'll get access to the Alien social application, and then We can talk about one of the things that you want to work on for the hackathon. You can add features while in social. And kind of see if there's a large code base, but that's why Henry and I also here to kind of help you navigate, show you where stuff is at, talk about stuff that we're issues we're running into, et cetera. So I'll leave this, I'll just stay on this slide for a while until we need to talk about it.
Just an idea for later development. Maybe looking into how you could leverage React Native for other people to deploy that don't know Swift and don't know iOS. And yeah, React Native has a very big community and it's growing. So if you can do like a bridge into the internal Swift API and expose it to JavaScript, and then you can expose those features to any JavaScript developer to do more stuff on it.
Oh yeah, so React Native, that's one of those cross-platform development.
Yeah, it's based in JavaScript. So I'm not talking about the whole architecture, doing it, obviously not, but maybe you could create a little library that exposes some of the core features, and then it would be easy to implement something new using JavaScript. Something to look at.
Yeah, so one thing is, of course, with the audio social stuff, so anything that looks like a general web application or anything, a lot of applications are basically, they use general concepts and they just move text boxes around and maybe one is more graphically pleasing than another. So it's usually pretty easy to do those cross-platform. The problem that makes this hard is when it comes to the parts here in the dark blue, even the light blue, then specifically the gray, right? And so on this middleware, like a lot of the gray is specific. We don't write the gray part. That's using the part that's particular on the iOS. So like, if you think about say with Bluetooth, Google's doing this stuff where they have Bluetooth in the cloud, right? So basically, you're enabling Bluetooth on any Android or not Android. What's the Google Chrome device? Like Chromecast? Yeah, Chromecast. Basically, if you have Chrome, Chrome in the browser, they have APIs where they're basically exposing your stuff. And then, of course, that's a large team working on that. But even that gets tough here. When it comes to doing that on every particular device, one thing that Android does is sometimes you might have an Android device and an application might not work on that device, right? Because there's so many different chip providers. Apple's to take control of the chip providers. That's why they can say, when chips are on this device, ours can work on iPhone 5. Right, like say anything like this, like SOS middleware should be able to work on iPhone 4S and up. iPhone 4S might be a little bit different, but definitely on iPhone 5, right? Because of how Apple manages the APIs. So there's that's why it's hard for you going from Android to iOS. If you're going on Android, you might design something that can take advantage. But if you don't have a newer Android device, you don't have Bluetooth 5, right? And if your device is older, you might not have Bluetooth 4. So when you start thinking about some of this communication, you can write it for Android. But if the people that have these devices don't have the wireless technology, they can't take advantage of it. So. So I guess, if there's anything else, like I said, we're going to be here the whole weekend. If you all think more about things that you think are easy for these type of applications, like if you had, think about think about Twitter, put Twitter in your hand and say, modify this network to do everything that you need for a disaster scenario, what would you do? And then, after you open your eyes, think like, oh wow, that's what it's on social. So if you can have something that's similar to Twitter, you can do almost anything you want with it to basically circumvent some of these issues that we're talking about that happen. What features can you add?
Have you thought about just these super broadcasters accounts? Like, let's say the government wants to put out a message. Will that work right now to broadcast to everybody? Or
sure.
I'm not sure if I follow that. You could only get messages from people you follow.
Oh, so that's the thing with the routing protocol, right? So initially, right now we don't do this, but what you can do, the simple way to do it is whenever you put an application, or even if you update the application, you add these government accounts in there automatically. So basically, all users are subscribed to that account, and they all will receive that information. So even with this case, so actually there's one a little bit, if you get back to when we talk about security. If you have no security or if you have no authentication, anybody can perpetrate this government. In this case, when we add those to the device, even when a device sees a particular information, they can say that that came from FEMA, that came from, I know for a fact that it came from FEMA, I'm trusted, nobody was able to modify it, assuming that the trust holds up in that application. But this trust that we're talking about, like I said, is usually occurred. So it's pretty, it's going to be pretty high. So if somebody's, not saying that somebody's not, I'm not a security expert, we know a little bit about security. Well, this is a security expert there. But when it comes to, these are some of the reasons why we use some of the higher ranges, because
it makes sense. So there's an easy way to deploy that if we wanted to have these government accounts that everybody's listening to. They could be done inside the framework.
Use the vetted applications. Kind of, I'm assuming that's how the cell phone devices handle like Android and stuff. Like when you download the application, they probably have an update process. They have to read that basically an Amber Alert comes out on this frequency, has this header data in it. It probably has something like that. The same thing when you download the application, you basically, these are the official government accounts, or whatever accounts is needed, and everybody's device always
continuing on this thought process about government being able to send these messages, can people also kind of like Facebook, that where remarks say, be able to send a message into to government, let them know I'm well, and then let's say that you are a user that wants to know if your family is okay, you can probably send that name to government, and then government can respond back to you like, yes, actually we know this person's safe.
Yeah, so yeah, that would be a good idea. So like so what happens in these cases is you have, just like with your backpack example, is that you have pockets of connectivity, right? So usually you don't have everywhere disconnected. And then even if everywhere disconnected at some point in time, at some point, somebody's going to get connectivity, assuming that people are working on the area, right? And so when you have these pockets, any leverage information like that, if you say that if everybody agrees that they're willing to collect family safety information or Facebook safety information, and then what happens is as soon as somebody gets internet connectivity, the information goes out, and because it is only sending a little bit of information, the government responds and says, yes, we have heard from that person.
Yeah.
So that is a
So interesting thing that happened here, don't know if you knew about it, but after the hurricane passed and the telecom was down, people would drive their cars wherever there was cell phone signal. You would see people lined in the side of the highway on the safety lanes, right? Just trying to get some cell coverage from call.
That's how you knew where the signal was.
Yes.
Yeah. When you see the cars stop.
So that's one thing that comes very interesting too with the routing protocols themselves that you can add to it. So most of the routing protocols try to somehow understand mobility, which in this case, in these scenarios, is the things that people typically do. People might crowd certain areas where cellular service is known, where food and water is at, maybe hospitals. Right? There's certain things that happen. And what happens is you might even have to have a dynamic routing protocol to kind of understand what's going on. If there's a natural disaster or people are moving in this way, maybe actually change the way information is routed. So I'm not calling it congestion, I'm not doing this. We're talking about that device standpoint. But yeah, so there's a that's why it's important, and that's why we're asking the question like, what are the types of information? What do you think is needed in a social network like this? What is needed in routing protocol?
Utilizing still that same thought process that we're using. One of our biggest problems that we had after a while is like, for example, when the president arrived, he said there were only 16 people that were dead. And because of that, we declared the place an emergency state, and that's how we were left by ourselves. But by having some type of a way of relaying that message that who's safe and who's not, we were being able to actually gather up data a lot better, and then being able to send this information to the United States where they were like, actually, yeah, they kind of can help you. Or these sectors don't have an exit road because the roads collapse, or these sectors actually don't have, who doesn't have water, who doesn't have, et cetera, you know. who really needs medical help or firefighters.
So, yeah, so along that line, that same stuff, like what do you need, right? So that needs water, food, stuff like that.
Just like checking, something that is simple to send the lowest frequency information that you can.
Yeah, so one thing, like features that can be added to the algorithm, so something like when you write it, so one, not the easy way, the way that would be easiest for the user, right? And somehow whenever a user input text, the app understood the text, right? So there's a text analytics to say, this user is trying to say this, or this user is saying food and water, this user is saying bridge, right? So that's the easy way for the user, that some machine learning stuff on the back end that I'm assuming it's not as easy, right? But the other way that you can do is that you can help better understand that information by adding simple classifiers that look nice to the user, but it's simple in our standpoint. So if the user writes a message and you use kind of swarm action works pretty well, where when you're writing a message, you can say, I'm about to take a flight, I'm about to actually eat at this type of restaurant. Well, basically, they have stickers that you attach to your message, which is something that we don't have in Element Social. And basically, if a user is adding a sticker to say roadblock, then we also start adding back in the crowdsourcing Stack Overflow. Multiple people say, yes, this is a roadblock. It's actually what kind of like the Waze does now with saying copies here and all that stuff, right? So, the crowdsource, and those are features that's important because now you can use that to assist the machine learning aspect of understanding the text because the user at the end of the day knows more than with the device. They have context, they understand context. And they're also, the user might know more than what's in that 140 character limitation that's currently there in Algorithm Social and in Twitter.
Yeah, but in that case, you also thinking about, in that case, you also thinking about the civil tax or some malicious person trying to redirect certain resources.
It's an interesting problem.
But it is definitely.
What else is
what's important? But from an infrastructure point of view, I think also the ability, like Joel was mentioning earlier about how can we leverage other types of gateways. Because we didn't lose also full connectivity. We never lost internet, one internet ports. T-Mobile lost theirs temporarily. We're actually just all underground capabilities. But it was mostly the transfers later that was separated because cell towers didn't have serial generators because they were either were stealing the diesel or still didn't generate themselves, so fiber optics were hot. Some were stolen, it was operating. So that was really what caused most. But you still have underground fiber that was working in certain areas where they had different organizations providing certain key infrastructure. So we were talking about this on the psychedelic fracture. Mesh has clusters in different areas in a sense, while it has certain gateways. It's not necessarily a full. You don't need to be using a full delay tolerance across islands, but you can have clusters. So I think that's where maybe some of the research could also be directed in terms of how we implement it on an island-wide emergency, where not literally truly need the entire back infrastructure, but mostly last mile and some transfer.
Yeah, exactly. So and that's why like the title of the talk said like supplementing centralized infrastructure, right? So worst case scenario, if your network goes completely down, you still have this really power network, which is going to give you some. But realistically, is you have connectivity in some spots. So really, you're trying to strategically press or push the information to areas that do have network connectivity that's not congested to optimize connectivity for everybody.
I have more of a practical technical question. Because you mentioned Bluetooth, Wi-Fi infrastructure.
This one's a quick, more technical question. So, since you don't need LTE in your device, would it work on your more latest versions of iPhone Touch or the cheaper iOS devices that have Wi-Fi and Bluetooth but don't have LTE?
Oh yes. So this doesn't use LTE at all.
Right.
Okay, so the thing is, I don't know.
It's just iOS, it's just,
Yes,
it's not
no,
iOS,
it
it's
would work.
iOS only.
It would work for those.
Well, I don't, the thing is, I thought that when I saw that Apple was, well, all right, so yes, it would work on iPod Touch, because iPod Touches have Bluetooth support. What I don't know is that, so say for instance, iPhone 5, or not, iPhone 8 and iPhone 10 have Bluetooth 5. The newest Samsungs have Bluetooth 5, right? And so I know is that if they did a refresh of the iPod Touch and they had Bluetooth 5, which just should be this level of Bluetooth 5 automatically, right? So yes, iPod Touches will leverage any iOS device, and I guess even the beauty of it is that with the new iOS 12 that's coming out, this was, the middleware already works on Macs themselves, on Mac computers, but as an app, this app should run on iOS 12 from the stuff they've shown on the videos and whatnot. Mobile iOS apps are running on it.
Also, you can deploy it in a laptop?
Yeah, on iOS, so that's what middleware works automatically with the laptop because it's really what works with both. But on iOS 12, you're supposed to be able to run iOS apps on any computer.
Sure. Okay.
Yeah, so with that, essentially, you should be able to run that. Now, of course, we know that it runs because we're testing. Well, there's two things. We're testing, you can test a lot on the simulator, which is right next to the computer. But that's also a little bit different because Apple's been disabling some stuff in Xcode when it comes to using the simulator and Bluetooth itself. So from there, it's connecting using peer-to-peer Wi-Fi and block a lot of the simulator. But once they open back up an app where they can run the app. So that could also be one of the things, right? In this case, SOS middleware runs on Mac computers. There might be a need, which I don't know what yet, but there might be where, maybe you have this SOS and this routing working on computers, running applications that use this on computers. I don't know if that'll be better than mobile devices. I'm assuming that most people have, more people have mobile devices than they have laptops. But there could be different scenarios why that might be more purpose, maybe different data.
We were talking earlier about storage being an issue with mobile devices that they can run on an actual laptop. That could actually, really high volume forward.
Yeah.
That's true. That's true.
You can strap that to the
Then
front
you
of the
guys
truck.
probably want to.
That's true. That is a good one. Like if you, because especially when you start recording character messages, you start adding some form of low resolution pictures. The computer is definitely not have any problem carrying thousands of those messages.
Well, and with the computer also, I would make it easier to modify it and add higher gain antennas if you wanted to. You can experiment around with that also, as opposed to, anybody who's opened up an iPhone, it's not like you're going to do a ton of modifications and then still be, a somewhat level device if you need.
I know one of the things that we're talking about too, that you brought up when you brought up Rotana earlier. I don't know specifics about Rotana. I guess I just assume that theirs, if you write to their APIs, you're allowed to use their Rotana to extend communication range. I don't know if that's true or not. If it's closed,
The Rotana expert.
Not a Rotana. Not a Rotana expert.
Most that knows about it.
But yeah, the SDK so far I've seen is discoverable only. Last time I saw it was discoverable only through their native app. But the Rotana itself, I don't recall that you could alter the antenna gain or transmit power, because I think at that point you may get. I haven't reverse engineered, let's say, the Rotana to see if the chipset itself and the antenna they have would actually go to a range where you get to see licensing to transmit power.
well, not even that far. I'm assuming because since Rotana has a longer range, like say you did your app or using Rotana, like the test app, was it if they have a library that says you have this library to your application, and since you're using our API, you can send information to Rotana devices. Rotana, since they already have their own extended range, that means
you can send any it was 236 KB, 5 messages per minute.
Oh.
Any type of payload. But that's a peer-to-peer payload. It doesn't have to be just text, right?
Oh, so as long as you conform to the SDK.
Right, correct.
Yeah, so
But it's 5 messages per second, 236 GB. Around that size.
yeah, so from a high end, it sounds like you would be able to, like, you could technically do routing. You could add mesh, no tenant is one of the components. It shouldn't be that hard to stop. And then if they have some restrictions on
I
that,
understand they wouldn't allow that. I understand.
yeah.
I'm actually, you mean if you could add, like, SOS middleware on, install it on the firmware of the GoTenant itself?
No, from the device. So GoTenant has, you said GoTenant has, and GoTenant says you can send any payload.
Oh, using it as, adding it as your interface, so you have Bluetooth, Wi-Fi, and any other local device. So would GoTenant allow you, theoretically, you go through the SDK, yeah, you can create like an internal gateway where you would, as long as you conform, yeah, exactly, students conform to their SDK and their payload requirements, the number of messages and the payload size.
Yeah, so like one of the projects would be opening it up to, and you can do that. I mean, that's one thing. So you would use GoTenant's range in their communication devices, but you would still be, in that standpoint, be running SOS middleware and all the browsing capabilities on top of it. Because they would just say, oh, well, I see a GoTenant device. I can see GoTenant has a broken range in my typical Bluetooth. Then I'm going to send it through GoTenant, if that's possible.
If the thing is, you connect through the GoTenant device on the device, it's Bluetooth to GoTenant. So it's not it's not like the GoTenant is going to be further than the BLE range, which here we're going to look at shortened because of our.
Oh, no, of course. But that's still good, right? Because GoTenant, once the information's on GoTenant, the two devices, does it store information or do they have to be connected?
It's only from GoTenant to GoTenant.
It's a closed system.
Oh, no, it's not like it's from device to GoTenant to device.
Yeah, it's device to GoTenant, GoTenant to GoTenant, GoTenant back to device.
Yeah, so then it should work. If it allows you to do that, you should be able to use GoTenant as one of the power mechanisms. If they open up that, you can write
GoTenant does have some memory, so it buffers some data. So I did notice that, say that I'm out of range. So let's say Joel and I both have a GoTenant, and we're getting by them on, but I'm here inside the core, and my GoTenant is not going to reach out because of the reinforced concrete. Then I walk outside to grab a coffee, walk outside. I'm trying to move to get. So I go outside, walk outside the door, and then suddenly it does find Joel in range. It would relay it.
Also, there's some stored recording.
Yeah, some limited stored forward. It wasn't consistent behavior when I used it, but it does happen. Like sometimes I wouldn't see no person messages.
Yeah, so I guess the question would be there, if anybody is allowed to write GoTenant applications, which I don't know, if anybody can create any type of GoTenant applications, then you should be able to run this SOS middleware as one of the.
Plug it in, right?
Yeah, plug it in.
That would be very good.
That would be.
I mean, it sounded from what they initially said, it sounded like that's what they were supposed to be able to do. But that could be something that somebody might want to look into. One of the
for the hacking project, for the hackathon, that would be very interesting.
That would be amazing because if we can do that, we can pretty much solve the whole mesh network problem, which is to put everybody to work together. But that's our main problem. That GoTenant would just work together, right? That's with like, let's say I have fire chat, and you have GoTenant, and I relay a message, and then he has Rich Private, I relay a message for you, for your GoTenant.
No, but I think that sounds like that's a restriction. That sounds like a restriction. Like to me, if you, based off what you're saying, as long as you conform, and that's the same thing with the middleware. As long as you conform to how they do a payload, maybe FireChat's not choosing to conform to how they do a payload. So that's why they're not using GoTenant. Or maybe they're not paying for licensing technology so they can do that. I'm assuming it's one of those. But if they have something that says you can write. We open up our API to allow you to write any application for GoTenant type applications. That means that there is, use that for parts of their library.
They have an SDK for it, right?
Yeah, they have an SDK, they have an SDK, and as long as you inform the API, but I think what you were saying, that it's a little bit of a stretch, say you're solving the problem of all mesh. It is a good add-on to have, because like you mentioned, you have an app here that talks to the GoTenna over SDK, and that is a native iOS app, and that app could talk to any other wireless interface, or if it send a message to SMS or whatever, then it could be a gateway, right? So that is one way to extend or connect the GoTenna cluster to some other network, whether that is gatewaying through an infrastructure Wi-Fi, or whether that is gatewaying through an SOS middleware through Bluetooth to another iOS individual who doesn't have GoTenna. So it could be a way to it. Yeah, it's definitely possible, but that alone won't solve all the
Nice guy, I can search over this and like.
Yeah, so I guess if there's no more questions, I think we want to talk about it.
It's literally a great way.
Okay, so all right, well, again, of course, we'll be here the whole weekend, so if you all have any more questions, we'll talk. Thanks.
So you gentlemen have the pleasure of living in Lexington. Yes. Well, that's the closest city you may recognize.
I've seen that.
Yeah, if you go up 64 far. Yeah. As I'm saying, I think you'd be better than being native in Kentucky. But no reason there. Yeah. Yeah. Well,
I'll stand by one.
so that's the corner, right where oh, yeah, you probably saw the sign. You're like cooking on 64, and then there's like 2 exits.
Yeah, that's right, yeah.
Yeah, no. Yeah, I know the one. I grew up in yeah. Yes, we have. That's kind of fun. Yeah. West Virginia, Southeastern Ohio,
If there's a necessity, where there's people with low those people have an iPhone, bro. And this thing about the sensor, right?
Yeah,
So,
exactly.
so you know, during the disaster. The ones who are least are the ones who are they're already don't even have anything.
Yeah.
So like the main thing that talk about is find a way of downloading without signing up. Just download the motherfucker on Hotspot or Raspberry Pi that you can just pass by. And no sign up. Just send messages, privately. If, for example, here's a crazy idea, if you want to like somehow validate your own identity for some reason, send a picture of yourself.
Well, and
yeah, because I like no, but I just
if you send a picture of yourself and then you know it just came out of there's a way of knowing if it came directly from something that you downloaded a picture and then just send it. It has to be straight up like out of your cell phone. Yeah, out of your device. Like the application will ask you take a picture. You know what I mean? Then you took a picture and then you secured it by fucking sending your own thing.
Yeah.
Oh, great. My worry is about the person's life. You know what I mean? Which one weighs more? You know, identification or all the cops or that or hey, I'm drowning here. Especially when you source data, and then whenever that person's closer to that user to be able to send it to the user. That's,
it
the message for our system.
You never see it.
But it's like store forward.
Store forward is like what's concept called. I guess it depends on which word you but like most of you probably stores forward and so
that is an interest-based routing and SOS counts. It's called a store.
I have been better for well, that is like I got
I think like
it's super critical. Yeah, because in order to have a proper mesh network, you're gonna have either everything pass it or somebody else to get close to that person. Super important.
Yeah, a lot of research.
I'm sorry, boarding and other authentication. You guys need in order to make an Android friendly and in order to succeed making this work for already out there.
So having It's underwater, so I don't know it's I don't know that they got the certificate it's another change it out. That could, again, we have a, yeah.
Well, here's something to give my experience at Rich Pride of Argent is that it's completely useless.
Yeah.
Yeah.
There's no one, I don't know, that's it. If it doesn't work, then it's not. What is the same? Changing out, we have to. I think I have to. So that take out. But also, it's a lot of like, it's a lot of like.
Well, that's why I said it's not exactly so that can it's not. So that over there they had.
We have in this type of sense, modularized preference. What we do with that framework. Sometimes you get crunchy, which is their wide environment. Sometimes they kind of you have to kind of you can do something. It's just essentially these are localized. Something it's more time.
Yeah, no, they are.
And maybe the time that you guys see then the things that got to be ahead of fire, Rich
Yeah, they don't.
Mainly was going to be 400 and do that like open source to people. Never did that. I have my friend that needs to like ask some questions. No answer. Actually, they offer him money. Oh, and then he offered him like $1,000. Insults there. With those two things, that's something you think you guys really great technology. We needed to, for example,
Revised method or
Okay. My back rotation, I want to mix in mesh network and blockchain. So for mesh network, especially those ones that are happening, they probably won't have the service. I can self-programming to sell the clients, etc. But I think you get into some of those very download long things where I sort of was trying to stress out for people that I programs. I like to do technology where they can. It's not like a post application where once you send out GPS there for the next 95 and start documents. You can't see nothing. Let's say the guy crashed their phone and you can't see it. It's not like a blockchain because it's under the ones that can fund the rescue missions. Government, great pressure on government to say, hey, we found out here is where it's not different. It's not just a victim, but welcome to the team, guys. Somebody just saying, hey, people out here, and be like, hey, here it is, and then this becomes a lot of transmission. Where they can't download it. So it's like, it's completely worthless. So only some of the ABS defense fund security part is actually maybe a hybrid. Most planes are using a kind of swamp trail. What's a nut? They want to go have everything. What's his part? Traditional he's the greatest type of fish. I mean, I guess like what shit relies on. So like if you everything all kinds of I guess I'm focused on tracking there's one thing the healthcare she had that last year. Even if you are getting yeah, so like if you build something I'm receiving your transaction. I'm going to do a nice so I think like provide you can see aircraft. So the thing is that this is built. What's something like reviews? It's almost like that's a lot of this is making that security. Probably there's time. Yeah, I'm kind of
Don't give me the equipment to do it. Tell you how to set it up, how to, they give it a free enterprise. I'm not sure.
I wonder.
Yeah, maybe that's the mind.
I use it for other purposes.
The application is downloaded, send me a picture of it.
At home, schools that do it, you also take a picture, and that's
Were there, and there was a live, also live. They didn't have any check to make sure it was a live person. Oh, the buffalo ones, you used to be able to drink it, they found that they fixed that. And a lot of the commercial brands, it's now like on the Samsungs and like they're supposed to be. To do a live check. And let's pass that, but that's the one thing that takes some. Yeah, you might be talking to me for like 6 months. Yeah, but it's really me, the beer in Kentucky. Yeah. So what
come out of the application, I gotta the application, not everybody that have a picture stored in itself.
Like, what's that, the application?
Yeah, so
but that's one of the ways it was not holding up in pictures, other pictures. In front of the camera.
Okay, that's how actually artists in the video, right?
There's no way you can have it.
Well, so I think at least there's more work on it.
That's why they've implemented the live.
You can do, there's like for playing where you can, but then you actually have to do that purpose. You do have to actually do the biometrics is good. That's all I can say about that.
That's why I'm saying this, because we know that the main problem is what's going to happen in application. So mention that application needs to happen first. Or the we'll make it, but we're trying to make it work for us. We'll try to use it to operate our company. Nobody tries to gotta sign up. Certified. That means that signature, you know, like that.
Yeah, I mean, ideally, if you have so, the one thing you're talking about is or I want to take a break walking. Okay, perfect. I can walk up.
¿Trabajaste con el TDRC?
So you create a knockout like
Pero siempre ya you know the fact? Yes.
Oh,
oh yeah,
Why not?